Hi, everybody. I'm Connor. I work for the DCC at the Children's Hospital of Philadelphia. I'm a data scientist there. I'm working on PEDSnet, and today I'm here to guide you through the PEDSnet DQA toolkit that we use. So to start off, everybody, please go to this GitHub link at the top. It's github.com/PEDSnet/tutorial.git, and I have it open myself. Everybody there? No?
We're not doing this in the RStudio in the browser. This is your own RStudio, right?
No, this is going to be in the browser too.
Oh, okay.
Yep. How's it going? Everybody there? Can we go to the page? If you still need it, you can look here. So, now what you're gonna wanna do is go to this green button, just click it, and this will give you a link. Just click the clipboard, and that'll essentially just copy the link. So I'll open the presentation back up. So also in your RStudio environment, at the top there's this tab that says console. You want to switch to terminal. You want to type git clone and then just paste the link. And that'll create this tutorial directory, which I have here. All right, so has everybody cloned the repo? Anybody still trying to navigate? I'll show you one more time. So just on this page, which is just github.com/PEDSnet/tutorial. Just copy it. Go into R, go to the terminal tab, and do git clone, and then paste it. All right. So I think, does everybody have it? All right, let's move on then. So go back to that GitHub page, which I hope everybody still has open, and just scroll down and you'll see a copy of the README file. And keep scrolling down until you get to this R packages portion. So these are all the packages you need to have installed in order to make the DQA toolkit work. You may already have some of these packages installed, but just for time's sake, copy the entire thing anyways. And you're gonna have to go back into the console part and enter it in. you may get this message if you have any of those packages loaded. Just hit no.
So you only copied the first line.
Right, but we're going to keep going through every line.
So you just pasted that into, what I was doing before was I had a script window and I was pasting into there and running from there, but you're just basically running in the console and then it runs automatically as soon as you paste it. Is that how that works?
Oh yeah, definitely. So those are essentially equivalent. You can put it in a script and just hit run or source, and that'll do about the same thing. So I'm going to keep installing. Oop, and this finishes. So I just reiterate, if you get a message asking to restart R for installing packages, just say no, and that should be fine. All right, so mine finished. So I'm going to move on to the next installation that's on that same page. So the terminal step, okay. So in order to clone it, you don't want to do that within the R Studio console itself. You want to go into the terminal and you want to just type get clone and then paste the link. Whoops, that's not the link site. Now the next step is going to be to load this DevTools package. So this is going to enable you to install packages off of GitHub. This may cause a couple issues if you don't have it loaded already for the installation of these next 3 packages. So that could cause a 504 error, I think.
I think the environment already should have SQL render and database connect.
Right, so if you had these installed in the previous section, then they should already be there. Just to reiterate, I'll just show it. I won't force the reinstallation. This last package was written by Charles Bailey at CHOP. It's for Argos connections. So I already had all 3 of those, so it didn't actually reinstall them. But just by show of hands, how are people doing? Are people able to install all these packages? All right, so is anyone still working on this step? If you are, can you raise your hand? All right, so I'll let people kind of finish up, but also push on to the next step. So now, within the tutorial package that we just cloned, there's 2 files that need your credentials to connect to the database. So one of them is under the resources directory, and it's called PEDSnet config.yaml.yml. And you're going to have to edit lines 4 and 5 and put your username and password into them. Likewise, under the Argos directory coming from the top of the tutorial package, you're also going to have to edit this Argos config.json file on lines 7 and 8.
So you say open this, just click on it to open it?
Yeah, so for an example, I also have to do it, so
So
it's just under tutorial resources.
we use like user 14, user on them.
Right. So if you're user 14, you would put user 14 here.
And then password.
Exactly. Yep. And make sure to save that. And then the other one, going back to tutorial, is under this Argos file. Go in there and click Argos config.json. And in lines 7 and 8, you want to put your credentials again, in quotes.
Where's the PEDSnet config YAML file?
That's under the resources directory from the tutorial. It depends if you have one of the 1 through 50. Oh, so everyone has? Everybody has master for the database connection? Okay. So I guess if you put user 14 or user 1, you want to switch that to master in these two config files?
And leave the password in.
Yeah. Password should be the same for every set of credentials that we're using.
Can you repeat it? What is master? If I am user 24.
All lowercase.
So if you're user 24, you want to be all lowercase master. So enter these to.
The YAML file and in the JSON file.
Correct. So here you should have master and password 1 on lines 4 and 5. And in the JSON file, you should also have master and password 1 in quotes on lines 7 and 8.
Database connection, it should be master.
So it should be master for everybody.
For DB user.
Because he formed it, is that why?
Only together for studio.
Yeah, I think
We're
it's just
using one.
logging in the environment is a different unique user for each person, and then logging into the database and sharing the environment is the same.
So I don't have DB user, I just have straight user. Am I in the wrong area?
Are you in the Argos file?
Yes, I'm in the Argos file.
So that should be just user. Right. That's correct. So this one should just be user, and it should also be master and password 1. This one, the parameter is called DB user, and it should also just be master and password 1.
He's switching back and forth, I got it. Thank you, Jose. Okay, got it. All right.
All right. How's everybody doing? Do we have these credentials added? Ready to move on? Yeah. So lines 4 and 5 in the .yaml file and lines 7 and 8 in the JSON file. Right, so these are all components of the connection information that, such as the schema that's pulling your common data model or your vocabulary schema or your result schema. I've already set those for you, so you don't have to change those. The only things you have to change are your credentials. However, if you were using this yourself, those are parameters that you would have to configure based on your database. So this is the moment of truth. Let's see if everybody can get it to work.
Do it all at once, Connor, or do you want to maybe do it yourself and have people hold off for a second?
So I'm going to do it myself, and I'm going to hope everybody can follow along. So we want to go back to the tutorial. And, sorry. You should see a little gear up here. You want to make sure to set this as your working directory, this tutorial. You don't want it to be the Argos subdirectory, and you don't want it to be the resources subdirectory. Make sure that you're in the tutorial top directory, and click from here, set as working directory. Very important. Alternatively, you can just type this directly into your console and do it that way.
So it's set command, left paren, double quotes, tilde? Or dot dot?
Tilde.
Tilde.
But the easiest way is probably just to click this little gear and hit set as a working directory. All right, let's give it a shot. So open up the run dqa.r file that should be in that same directory. So if you can't find this file and you set some other directory as your working directory, make sure to switch over to here and set this as your working directory. So open run dqa.r and then just click the source button. If everything works, you'll get this little message that says log started.
You just click the run button up.
You want to source it. So if you made it to this point, you're probably good to go. So if you've got your working directory set, you want to open run dqa.r, and then you want to just source it.
So if you did, it's on its way. Oh, did it said it installed.
Has anybody gotten the little message that says log started? If you've gotten this message, can you raise your hand? Okay, so not a lot of hands. So what is the other message then? So you didn't get this log started?
I got the 3 info messages with the times that you have, the timestamps. They don't have the log started, but it's not back yet. I don't have the little pointer either.
Yes. Yeah. Still processing.
So I suspect that that has to do with us all using the same database connection.
And I have a message that says install GitHub.
Or do I have to run the whole thing again?
Right, so to be clear, if you got this far and you got those 3 messages and you didn't get log started, it's because I'm already connected to the database, so you can't connect to the database.
But what I'm asking is, when I can connect later, I don't have to run the whole thing, right? I just have to run the last steps.
Yeah, you just have to source it again, and then
Okay, so
from there, everything will work. So now, I'm going to keep pressing forward. So the command to just run everything at the first level of our DQA is run DQA level equals 1. And then you just kind of let it go. So what it's doing right now is it's going through each of these reports. These reports mirror the domains within OMOP. And so it's looking at each of these different domains and it's trying to create a bunch of plots. It's looking for issues and it's performing checks. These checks are defined under library. And it looks like level 1 has run successfully. Now there's 2 levels to it. As a reminder from Hanya's presentation, the first level is univariate and the second level is multivariate. So if we just run level 2,
Where do the reports appear again?
the reports will appear under the results directory and it'll be split into 4 separate subdirectories.
Just a question.
Yeah.
Unlike Achilles, this does not generate summary files. These queries run directly against the OMOP data, the OMOP CDM.
So I would say yes and yes. They are querying directly, but there are summary files that are written in the results directory after you've executed the DQA.
But the query doesn't run against the result.
No.
I mean, it makes it tougher to figure out what Achilles is doing, like if you have Achilles heel error, because you can get the query that Achilles heel ran, but it ran that query against the summary table, and then, so you're one level behind and figure out how the summary table was written.
So any information that it needs to check query data against is actually stored under the data directory under previous data summary. So what this includes is something like this total counts.csv file, wherein it is recording the total number of rows. These are all just toy data entries, but this is supposed to record the total number of rows from each of the domains from each of the constituent reports. So for example, if you were running the condition occurrence domain, you would have, say, 100,000 individual rows. This information is used for a couple of the checks, such as the unexpected difference between cycles, wherein we look at if there was a drop in the number of records between data cycles, or if the amount of data grew by over 5%. And then that would cause an issue, which I'll get into in a bit, that we have to essentially communicate with the site about what may be creating that. All right, so level 2 finished for me. I'll also briefly show you that suppose you're running your DQA. It takes a while sometimes, especially if you're working with a large amount of data. So you may not want to run every report at once. So there is an option to go through individual reports. It's called generate single report. And then the first parameter is just the level. So I'll say 1. And then the next parameter is just the domain. Now suppose you didn't really know what they were called. There's a convenient error message that'll tell you all the acceptable domains. So I'll just run that again real quick just to show. The condition occurrence report generated successfully in its own. It didn't run every other report. And so there's a little bit of versatility there in how you break down your workload. So now that this is run, you'll have a results directory, which I've already predefined in the tutorial package. And it's split again into these 4 separate subdirectories. So in the images, for example, you have something like this that I've already pulled up, where you're just looking at distributions of different types of visits. So inpatient, emergency room visits. If there's any outpatient visits, that would be included here as well. Another example is the distribution of care sites. So there's a bunch of plots that are being generated. However, an easier way to view all of them would probably be under the reports directory, where we have these sort of markdown files that pull in each of those images, as well as some summary information such as missing rates and the total number of rows, the total number of distinct values of certain fields, and things like that. So going back to the results directory, we also have this data file. So now, earlier I showed that total counts.csv, where it was looking at the total number of rows and checking for an unexpected difference. But in order to do that sort of comparison, you have to record what the previous value was. You can't really check if there is a big switch in the amount of data between data cycles if you don't know how much data was in the last cycle. So every time you actually run this toolkit, it generates this total counts.csv for you, as well as a couple other files that are used in other checks. The 2 from here that you really have to copy in between separate uses are total fact type counts.csv and total counts.csv. A lot of this information will also be present in the slides, which I'll send around later. But to continue on, the bread and butter of this toolkit is really in the issues directory. So these are the issues that were caught by the DQA that we will relay back to the sites, and we're going to discuss with them about what could be causing them. So as an example, so there's an inconsistent null distribution between source values and concept IDs. There's a lot of missing data and a very large variety of issues. So let's come back to this from the viewpoint of somebody who's a constituent site. So this is the CHOP GitHub page, and I should also mention very quickly that we use our Go program, which was mentioned a little bit earlier, where in order to actually connect these .csv files of issues with GitHub accounts for each of the individual sites. So to reiterate, these issue.csv files contain all of the issues that the DQA found about the constituent data. And we run a Go program, which is outside the scope of this tutorial, in order to connect these CSVs with GitHub and intelligently gauge if an issue has already been brought up before, so we're not rehashing the same issue, if it's something that's characteristic about the data of the constituent site, or if it's a new issue, it will post it for us along with a few tags. Alternatively, if it's something that's already had a solution proposed and yet the problem is worsened, it'll also post that. And if an issue is still under review, it'll just post an update about how that issue is doing now. And so to show you what that looks like, this is the CHOP DQA workflow repo. Under there, this is an example of one of the condition occurrence reports, those markdown files I showed in the reports subdirectory of the results directory. And so you can see all these distributions, as well as a lot of summary information.
So this is one site's page,
The,
or is this the aggregation of all the sites?
this is one site's page.
So, but only that site will be able to see that, or can everybody see that?
Only that site would be able to see that. And so this is an example of one of the issues being posted to GitHub. So in particular, this is a temporal outlier issue, and it shows a dramatic change between months, looking from a month-to-month perspective, and the number of records. And here's that in graphical form. So we're curious as to why there's a large amount of data and a spike here, and I believe here as well. And so this is the sort of issue that a site would have to go and investigate. And you can see a brief conversation of that here. And it was determined that this was coming from flu season. And so there was an increase in the number of records. Yeah. Just to quickly wrap up, I'll just show you, this is another example of an unexpected change in the missingness. This is actually a positive thing the DQA caught, where there's an improvement in the ETL process. So we mark that as persistent. It's characteristic of the data. It's not actually an issue with any sort of ETL, but it's something that really catches our attention, so we rank it as high. So the cause was, again, a non-issue improvement in the DQA workflow, and this is just persistent. And finally, there was a small ETL issue where we were missing a lot of data in one field. And so we were able to just quickly get a commit in that ETL that fixed that problem. And so this is an example of an issue where a solution was proposed, and it was due to an ETL issue. And so it's really these ETL issues that we're chasing after, because they're things that can be easily fixed that'll improve our data quality across all sites. And so I'm sorry that there was an issue with the database connection. I'll send around the slides, so maybe you guys can try on your own. But thank you for your time.
Okay. So if you're all still in RStudio, the one thing you're going to have to do is go to your console, because you're probably still working in the tutorial environment. So you need to set your working directory to tilde. Oh, wait. What on earth? That's you, though.
Yeah.
That's not me.
Still. Okay. You want me to do?
Did I just hit cancel?
Yeah, cancel's good.
Okay. So do you set working directory tilde, and then that will set you up outside of the environment. So to install DQEC, it's similar to PEDSnet. You're just going to do git clone. I'm sorry, you're going to go to terminal. So you're going to go to terminal, and you're going to do git clone, and I have the URL right here, HTTPS.
Can you just
set WD, parentheses, some quotes, and tilde. Yeah, let's see. Restart the session? Okay. Session. Okay, so we're going to restart the R session. So just go to session up top, up here, and you're going to work down to restart our session. Okay, so we should be set up. So now, okay, so who's actually following along on their computers? Okay, I just want to know how many people we're waiting for. Okay, so in terminal, let's clear this. In terminal, you're going to hit git clone https semicolon. TRBERG.
Is there a space there?
No, no space.
.com keyboard.
Yeah.
Oh, slash. I can't see the slash.
And I already have it installed, but you should get the installation message. Am I missing? Obviously, the easier way is to go to the GitHub page, hit clone, copy link, and then put it in there. But there's a little too many steps just to make that happen. So, okay, who's having trouble with this one? Oh, in mine? Oh, in my console. Ah, there we go. All right, I still have it anyway. Okay. Okay, who is not here? All right. Do you guys need help? Are you good? Okay, so the next stage is you're going to go back to your console screen, and you're going to set your working directory to DQEC. Okay? All right, and then under your files, you're just going to click into DQEC. And that's where all our files are. All our files are right now. Okay, so the first step is you're going to go scroll all the way down to the bottom of your menu, and there's going to be run.r, all capitals. You're going to open that up, and let me. All right, since we're done with GitHub, I'm going to get rid of this. Okay, have we all set our working directory? Who has not done this? Okay. All right, so down here you're going to say set working directory DQE-C. So SETWD.
So some user was running into having a login to github.com. It requires GitHub username.
All right.
It requires
Yeah.
Maybe I had them to load it. I don't know why.
Okay. Okay, and then has everyone opened the file DQEC in their file side? Who has not done this? So all you're doing is just, it's in your home directory, just go to DQE-C. Okay? All right, and so then the next step is you need to open up your keys.r file. All right, so go find key.rs. All right, and then you just need to input your username and the password. Okay, so it's just me master and password 1. All right, and just a side note, the reason you have all this commented code around it is if you were to uncomment all this code and then leave username and password blank, it would actually give you a pop-up because previous people who were using this tool didn't like having their password and username stored in there. So you can activate all of this and it will pop up and then you can input it every single time you run this. It's up to you. Okay. So has everyone gotten to this point and filled in their username and password? Who has not done this? Awesome. All right, so we're going to go back to run. And just for your information, I have all the information filled out for you, but under DBMS connections, depending on your database user connection, since we're in Redshift, we would go to Redshift and you would have to pick your database connection and then you would have to fill in your URL, the information here. So you'd have to put in your connection string for your curl string and then your port and then your database name. That would be for Redshift. It'd be slightly different for Postgres. So just FYI, when you do this in the future on your own databases, be sure to come in here and fill out the correct information. Okay, so we first need to install in run, so we're in run.r. We first need to install all our libraries. So you can put your cursor by source, DQE functions, libs, and you can just hit run. And this will ensure that all your packages are formatted and installed. All right, once again, you put the cursor behind source, this here, and then you just hit run. All right, who has not done this?
What's that do? Just run the kernel line?
It just checks to make sure all your libraries are installed. If you didn't, it would actually go out and it would install them for you. All right, now we need to initiate which common data model we're going to be running this against. So you guys, I think it should be empty in your guys' version of this. So just fill out OMOP v5_3. And the current models we support are Picorian. You can pick any one of these. But we're going to be running version 3. Okay. Who has not done this? Okay. Oh, so we're still in the file run.r. Okay, next step, you come here to SQL, you fill out Redshift. However, we do support SQL Server and in Redshift. It's kind of Postgres, I wouldn't trust it though. And then Oracle, we're still working on that. But we're gonna fill in Redshift, and then you just put your cursor next to that, and you hit run, sets that variable, and then we scroll down a little further. We have to submit, we have to do the correct schema, yes? Oh, I'm sorry, yes. SQL Redshift. Anyone not have this? Okay. So then you move on down to schema, and I believe that you're empty, but we're going to run this on the SynPuff 1000 records data. So you're going to put your cursor next to that. You're going to fill that out, put your cursor next to it, and just hit run. Establish that variable. Anyone not done this? All right. Oh, yeah. So CDM, you're just doing OMOP v5_3.
Just kill your terminal and make it larger.
Okay, perfect.
And hit F11 to go full screen in the whole browser. You have a lot more.
That is my, hold on. On Mac, I always forget which one is.
Full screen. I don't know how you do that.
Oh, exit full screen. I'm in full screen. Yeah. Okay, so has everyone got to this point for the schema? Right? Okay. Next stage, you need to, since we don't have any prefixes for this, but some people will have prefixes on their table names, you'd have to establish that here. And then put it in your organization. Obviously, I'm from UW, but you can fill this out for however you want. Put your cursor on it and just hit run. Okay. Okay. Who has not gotten to this point?
It's okay. I'm a friend.
Okay, cool, awesome. All right, so we're going to run our first set of tests, and considering that we've kind of been crashing the server a little bit, I kind of want to try and do a wave. It really shouldn't take that long because I've run this query a couple times, and I believed the first time I ran it took forever. Second time it was cached apparently, so it just kind of went really quickly. So if we could have these first two tables run this first. So run source without R, you put your cursor next to it, and you just hit run. It should be connecting, grabbing all your variables, and then it should end. How are our first two tables doing? Prefix not found. Make sure your prefix is equal to just an empty string. Okay, we're clear? All right, next two tables. We do like a virtual wave. All right, and so what this without.r package is doing is it's going through and finding all those clinical variables we had talked about earlier on the slider, and it's establishing what percentages of the patients are missing those. You can see through all these different messages what exactly it's testing for. It's also testing for orphan keys, as well as establishing how big your tables are, how big the rows are, and it's establishing all that initial information. All right. Has this entire side done without .r? Who has not done it? What? Okay, it's not finished. All right. Okay, so you're going to go up here, and you're going to go to CDM up at the top of your run package, and just establish your CDM variable. So you're going to put your cursor on it and just hit run. In column names. Yes?
So just to report, I was able to follow, but it wants a Redshift jar file, and it's hung up on that. So
Oh, so it
server, I'm on the test 2 server, so I'm not logging anymore. So I violated your.
Yeah, that's fine. So does it look like this, downloaded?
Yes, it didn't finish the first step. Find URL. And Robert is saying that it's somewhere in the local file, so I can rewrite it.
All right. I mean, even if you don't have it, it'll download it pretty quickly. So I'm not really sure why it's not throwing it there. Okay. So for that one, if you go to, this is just for that error specifically. So it checks to see if the file exists, and then it downloads it right here. So that's in the Connect Redshift server.
I'm going to try to resuscitate it.
Okay, all right.
I'll try to go to the source and fix it.
Okay. And on this side, have we started running without .r yet? So go ahead and on this side, try and run without .r, and we'll see if any more errors. And then you still have what's your error again? Okay, who is still not run without .r? Okay, and you're still waiting to see to get a download. All right, so I think the majority of people have been able to run it. Is that correct, or were you able to get it through? Still connection. So just to reiterate, so on keys, the username is master. It's not the user number. So if you're getting a connection error, try checking your keys again and make sure that your username is master, all lowercase. So if you haven't been able to run without, try again maybe. But on the source, we're only making a couple queries here. So we're going to do comp-test.r, and this is the completeness test. This is where we go through every table of every column, and we look and see what are the percentages of empty versus nonsense string. So go ahead and put your cursor over that, and then hit run, and let's see if we can take down Amazon. All right, so mine went pretty quick. I don't know how you guys are going to look. If you didn't run without .r, then it's not going to go well on this second one. Okay. Who has not been able to do this? Okay, and you're still waiting on the jar file?
I yanked it out of the thing because it's in the folder, but it probably was the wrong move because
Okay.
source is running for it.
Okay, so put the jar folder back into where it was, and then comment out the download statement, and then just skip that part because it should be present. And I think it's a small typo on my part why it's checking every time.
That's what I did. No, I just
Okay,
did a condition. So
and it's just timing out. Okay.
I'm gonna step through without R. Just,
Yeah. When you do this on your own, all you could do is just load this file and hit source once you fill out all the information, and it should just run on its own. I just want to kind of talk through everything that's happening. Okay. So if you have been able to run comp test, who has not been able to do that? You, the what? You ran. Okay. So in the meantime, for everyone else, you can now generate your report. So if you've been able to run this, you're just going to highlight these three lines right here, and then just hit run. And it's going to generate a report. And you will see some red text, and I believe at the end of this, it will say there's an error, but ignore it, it's fine.
Can you run them one at a time?
Yeah. Yeah, you should. I mean, okay. Yeah, you can run it one at a time. It's the first line here is just to deal with the fact that we can't display PNGs in a certain manner. And this shouldn't be running on the SQL. It should just be running on the reports generated. So yeah, so you'll get this error here. That should be fine. Just to show you, all these two lines without .r and comp test have been generating reports in the reports folder down here. And each of these is where this is your load details, frequency, and completion details, and then your overall data model. You're welcome to go through those if you want. They're not really that important. So once you get to this point, who has not been able to run this, other than the people still working on without and everything else? Okay, so now you should have a report.html file that has shown up in your folder. So you're going to click on that and just view in web browser. And that's going to load this up, and here's the report that this generates. So you have your table of contents, but as you scroll through, it's going to be you're going to be able to see the different table information. So at the beginning of each section, it's going to show you the raw data of how big your rows are, how big the table is, how many rows each table has, and then you're going to be able to visualize it a little more. So this is the cross-reference of what your database system is compared to the reference OMOP 5.3. So we don't have all the tables present. So the ones that are not present are going to be blue, and the ones that are present are going to be orange. So we don't have a cohort table. We don't have, the cohort table is not currently present. We don't have visit details or specimens. So you're able to see how well overlapped you are with the official OMOP standard. The next one is going to be file size and row numbers. Because our data set is so small with only 1,000 patients, and I didn't want to crash the server going with the 23 million, your concept, ancestors, and relationships are going to be massive. However, in the previous figures I've shown, about half of this is going to be your procedures or conditions, and then the other, so you'll be able to see how big your real tables are with some real data. This is a kind of another similar visualization, but this is actually showing all the different pointers for the main OMOP data model. And the light blue means that you do not have that table in your database, and the dark blue means that you have observations there. And I believe the size has to do with how much data is there, if I'm not mistaken. As you scroll down, we get to the next section. Here's a new table with a bunch of information. The frequencies of rows. This just is a summary of all the information that we've pulled, and so then we can start visualizing it. So this is the primary loads across different time periods. Because we only had one load, we have one data point today. But if you were to continually run this report and not lose your previous reports, then you will see these be linked together, and they'll be able to compare sizes across time. And these are for each of these different main tables. Okay, so then we're going to look at the proportion of missing data by type in loaded tables. So we can see in care site that that all the data in care site name and location ID is missing. But we have no nonsense variables that we've been able to detect yet. And so this just means that these are empty, right? And so you can go through each of these tables and look at the percentage of missingness in each of these tables. So concept is missing, standard concept, about half is blank. And so even though that probably may not be a problem, we can keep scrolling through. There's a lot of tables you can look through. Death is missing, cause, source, value. So you can just kind of go through this, and this will help give you a picture of what you're missing in your data. Drug exposure is missing a lot of information, so in a real database, we want to go in and start checking those columns out. All right, so if you scroll all the way to the bottom, this is where we start looking at orphan keys. So I'll reiterate, like I said before, we're looking for person IDs for this visualization here. Where person IDs are expected in the other data tables, the question is, do we see any keys in those tables that are not present in the reference table person, right? And so I do.
Ask a quick question.
Yes.
So if that happened, then one of these lighter green or different greens would be taller than
It would be taller, but it would also, we do it would be red. So you'll see a percentage of unique IDs in the number that it'll show up in red.
Okay.
Same so we do care site, ID, visit occurrence. So we don't do every single possible ID. We just this is more of a sanity check for a couple of the big ones, person ID and everything. Then the next section, we do completeness of common key variables. So this is going to report on what percentage of your patients are missing some viable code for each of these different categories. So in this data set, no people are missing a gender code at all. 5% are missing an ethnicity. 6% are missing a race. The medication and the condition are really just looking for a viable ID. So this is just a non-null string. And we're seeing which percentage of patients are associated with just an ID for the medication table and the condition table. You could add an observation row here, but we chose not to do that here. Also looking at how many patients actually have a visit. So 15% of patients are missing some visit in the visit table. And then we can look at other variables like weight, height, and heart rate and blood pressure. And so who is not at this point and who wants to be at this point of those people that aren't there? Yeah.
So what I would suggest, is there a way to post the R markdown or the HTML report on GitHub somewhere where people, even if they totally fail, running everything?
Yeah, I mean, it's just an HTML file.
If you're using Synpod, it shouldn't be a big deal to post it.
Yeah, I can post it. Yeah, that's no problem.
So can I ask you a quick question?
Yes.
You're talking about the one where there was one data point, because we've run this once, and you said if you save your report, so if I go back into the reports folder and there's like a DM, ops, V5, blah, 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 and it has the date on the end, that's how it's going to
Yes.
process them.
Yeah.
Okay.
Yeah. So the way, so we just tack on the date of today's date, so it'll automatically, store everything like that. Yeah. Are we running out of time or?
Getting closer to all right.
All right, how much time do I have left?
You got 3 minutes.
3 minutes. If you're interested in adding on more clinical details, so for instance, I had an example where we can look at clinical observations. I'm going to run through that really fast. Maybe just watch. Don't follow along. So in order to, if we want to add another line here and ask what percentage of patients are missing some sort of key clinical variable, you can go to Athena You can find the concept ID codes that you think are in your database. And these are going to differ across databases, as I discovered when we validated this tool between Tufts and UW. We were coding blood pressure, one with Loink, one with SNOMED. So you'll run into those issues. So be careful. The other thing, so if you want to add to that, you go to OMOP functions, and you go to OMOP-without. And so in here, each of these sections, there's 3 lines right here, gender, capital gender, without gender. You just need to, in order to add a whole nother test, you just need to fill these out. So the one that would probably be most useful here is we're going to look at height parents. So this is to test for a height variable for a patient. So what you would have to do is figure out what within the concept ontology, and you can explore this in Athena, what is the highest parent of which all the children concepts of that code are a viable code to test for height. So for each of these, for height, these are all parent codes within the ontology that when we put it into this function I built called getChildConcepts, it will go through the ontology and grab all the children concepts, put it into a new list, and then we put that into this without height variable. So we use the function isPresent, and we can query them. So then we have to figure out where are those variables stored. So we're gonna test the measurement table. We're gonna query against the column measurement concept ID, and then reference date. What is the, it's a quality check to make sure you don't have, patients born in 2050. And then we input the list height here. So this is your capital height where you've got all the child concepts. And then that's just gonna go through and query the number of person IDs versus the number of person IDs that have a concept within this hierarchy versus the number of patients that don't, and then that'll output a line onto your README. And so when we take this without height, you take that without height variable, which has all the final information, and you add it to this withouts list. That's it. It will just tack on another result onto your reports once you run this through. So to give you an example of quickly how you could add, so we could add like a genetic test, let's say. Okay, and I have my test here. There we go. So it would look something like this. So in here, I've already gone through the Athena ontology and looked for the concept, and I know this is present in our data because I went and looked, but I went through and looked for the highest genetic finding variable, and then this is going to go through the ontology, find all the children, and then you input this into without gene variable. You can then add without gene to your without gene. And so once that's been added, and let's say you were to run everything again, please don't crash on me. It's going to go through and it's going to add that without gene to your list of possible. All right, once it finishes running, I'll reload, then I'll be done. Yeah. And I know I went really quickly through this, so if you want to add your own clinical variables, you can email me. But it's pretty straightforward just to add those 2 to 3 lines.
So to be clear, is present is actually reporting is not present.
Percent not present, yeah. But so, yeah, just to be clear, yes. All right, so now that we've redone this report, we can go down to, and there's genetic screening. 98% of patients do not have a genetic screening, but now 2% do. So that's how you could quickly and easily add these clinical variables that you're interested in. So A1C hemoglobin tests, things like that.
So the threshold, the colors of the dots based on thresholds, that's basically a high level. They're all the same. You can't set them for one. For instance, it might not make sense for weight to be 82% missing. It might totally make sense for gene screening.
Sure. It's just purely on some percent threshold, yeah. So, any final questions?
When you put in the concept ID, is it a standard concept or classification?
It's the standard concept ID within the OMOP concept, yeah. So the issue is, so you can go to Athena, athena.odyssey.org, and you can explore this, and you can actually look at the hierarchy and move up the hierarchy as you know which clinical variables are related.
But I think he might be right that it's a standard concept equals C.
Oh, yeah. Versus S, you mean? Right. So I know in our database we have non-standard concepts that have been really annoying to work with. So just be aware that each individual database will be different. One final note, if you find that this report, that you know for a fact that this is not representative of your data, you can go into each of those tests and make sure that they're grabbing all the concepts. Either if you have concepts outside of that scope, you can add new parent concepts to each of those tests to make sure that you're grabbing everything. All right?
That's it.
Yeah, that's it.
Thank you.
Thank you.
That was terrific. That was, I want us to appreciate this was 3 very lengthy, fairly in-depth kinds of, processes you were all being asked to go through. It was the first time we've done this tutorial, and we were trying to do it on a schmancy system that's going to allow us to run many people simultaneously. So appreciate you kind of working with us as we work out on the kinks on this. But I thought all the presenters did a great job. And the next spot on our agenda is for Q&A. I had it. That was a lot of material, obviously, and presenters did really, really well at trying to get through everything they wanted to get through in a short amount of time. We wanted to expose you to a lot, but I'm sure it raised a lot of questions that you didn't have a full chance to answer. So I'd like to throw it wide open right now to everything from questions that came up when Michael was describing the overall framework for data quality, to installing any of these tools, to how the tools are used, anything that's occurred to you that you want to open freely. And let's see, the gentleman all the way in the back row first.
I'm not a Odyssey user at the moment. I'm sort of in the private sector. I'm just preparing for some Odyssey to show up from one of our customers sometime. But all of these approaches have a similar architecture. They have a bunch of scripts that are packaged up some way, and at some point you run them over your database. We do something similar to that, and in addition, on a quarterly basis, going back about 12 years, we want to difference one quarter from another to see if we've gotten better or worse and so forth. And you can't diff visualizations, so I'm wondering if that's something that's come up, or are all these outputs stored in some sort of common data model of their own, or if someone's thought about that.
The outputs for us are in our own schematic that we then run visualizations on.
So we're currently looking at saving our outputs in a different sort of way, and that's one of the major projects on our plate at the moment. If you're trying to get a quarterly perspective, you could actually probably just change a lot of our functions that are making a month-to-month perspective to a quarter. I think it's just
But put yourself for a moment out of out of the hospital environment or into the private sector, and you're a busy manager. And I'm the vice president, and I want to know in just one page how much better we are now than we were last year at this time with our 175 clients.
So I think that the answer is a little bit complex because you have to define first what better is. Is it just the number of issues? Is it the type of issue? But I know that we, as Connor said, we're trying. That a major thing that we're trying to do is make it more queryable and try and figure that out. But we do for each cycle in the repo have results from previous cycles, so that you can look at that and do comparisons over time. But it gets tricky when you're asking what is it that you're trying to measure.
I realize there's a lot of details, and I wouldn't expect green light, red light, yellow light kind of thing.
Yeah.
Although some people like that sort of thing, but just. Maybe not go down to the granular level of 180, but just a general idea at some level, is my data quality improving, problems, that sort of thing. And if it was in a database.
So for us, it's currently, and you can speak to it as like a bunch of CSV files in GitHub that are stored based on the data cycle, and then you can query those.
Well, that
raises a sort of follow-up question on a completely different topic, but it's related to it. So we have some customers who are very protective of their data. Some government, some pharma. And there's a possibility of PHI leakage in test results, right? Could be patient IDs and so forth. And I'm sure most of you protect that sort of thing. But there's also a second level of PHI leakage, which is not necessarily one of the 18 HIPAA identifiers, like zip code and so forth, but aggregate data across other things. And when I participate in audits from pharma companies, this comes up all the time. It's how do we protect? And I'm seeing, just in a general way, it's not really a criticism, but, you know, because I've been a developer for a couple decades, just files all over the place. CSV, JSON, database things, where you can have interfaces, browsers like SQL Developer and PG Admin, where you can just browse tables and so forth. And so what's the general consensus on encrypting data in the database or hashing some fields, or just, you know, just maybe address the topic of protecting the PHI stuff?
So we like to rely on some level of stepping away from the original raw data, the Achilles heel pre-computation. You can specify the minimum threshold count there. That's one level which is there right now. And when we write an IRB, which we worry about as researchers, we try to argue that what is used as input is not the patient level data. That helps a lot. But besides that, we are not trying to encrypt the JSON. I would just refer to other security experts, but so we worry about the data quality problem, but the security problem should be somebody else's job to simply say, secure the storage of this output for us. It's out of scope for us.
And there's small cell counts too. You can specify periods that if you have fewer than 5 cells, that
Speak up, please.
Just also there's a small cell count setting in Achilles, for instance, similar to what Wojtek was talking about, where if you set it to a certain level.
That's what I meant.
Was that what you meant?
Yeah.
Yeah, it's the same thing.
Right.
I'm just repeating Wojtek then.
But I want to raise this completely different issue along this line, and that is reputational damage. Forget the sort of the PHI specific regulatory issues and stuff like that. We have many people. We did a survey about what are the barriers for people actually sharing their data quality results. And one of the #1 issue is embarrassment to my organization that someone will see something in an area that we missed. This is the organizational embarrassment, and then the individual investigator, oh my God, someone will find something in a part of my data, quality metrics that impact negatively on my findings. And so, completely independent of the technology, of the HIPAA, the regulations, whatever, I'm sure many of your clients are, government and pharma and others, that they, Regeneron or, Merck or what does not want their data. Now we try doing obfuscation of, data sources A, B, C, D, and E. Believe me, there are ways to infer just merely by the size of the patient count. We know who our dominant healthcare provider is in the Denver area, and we know who our dominant pediatric healthcare provider is in the Denver area. We don't need, it sticks out. So there are other issues of confidential and concern. And again, in our survey that we did about why people don't report data quality findings, reputational concerns were actually quite high.
So just going to stop the conversation on that right there. I know other people, there's a whole section later on where people are going to be talking about this. And so I just want to make sure we're getting to as many many questions about how things actually run and what they're for, and if we have a dedicated section to that whole topic, I think we're going to want to move on. I do want to really recommend the paper that Michael just mentioned, though. It's an excellent survey of all of those things, and it's highly relevant to all of the issues of creating a culture and the kinds of trust and the kinds of things that barriers to trust that need to be overcome through establishing a community where that's common practice. So highly recommend that. And Melanie, you had a question.
Yeah, so we've been presented with a couple different frameworks and different quality tests and stuff like that. Is there an overall framework? Are these quality tests that we ran based upon a framework, or?
Well, they're based on the conceptual framework. Some are, more or less. But one of the last slides in my previous presentation, and then also will come up in the next one, is what we do not have. So that, the overall answer is no. And that is, what we'd love to have is, irrespective of the tool that you use and how it gets there and what platform they use and whether or not you're an R bigot or a Python bigot or a SAS bigot, if we can at least get you to put your results, your data quality results, into a common results data model, then it would be irrelevant how you got there. So this is the architecture of Achilles. Achilles does the pre-computations, and then the tool, one tool, Achilles heel, picks that up. I'd like to see 7 tools pick that up, and I'd like to see 7 tools feed into that model. So what we're hoping, and you'll hear a little bit about the annotation work group, the OHDSI annotation and metadata work group is trying to move to that in that direction. So I'll introduce that in that. So we're not there. We do not have what I call a DQA, Data Quality Assessment CDM, DQA CDM. It's a mouthful. A common data model for data quality assessment measures. But whether or not it turns out to be the Achilles model or maybe even the legend results model that we heard about yesterday, that's what we need to be able to get to what you want. And then it doesn't matter what tool you use to calculate, to do your computations, nor would it matter what tool you use to do your visualizations or your checks. That's future research to be done.
Is there more? Yeah, you want to? Oh, Karthik.
So just along the lines of what Michael was commenting on, kind of a follow-up question is, Michael, you said you had a student who did the analysis of the various data quality measures, and you have that table in your paper. Do you have an output of that of saying, okay, well, these 100 rules actually span across all these networks, and so that would be part of that annotation data model that you're talking about?
Okay, so we've been asked to repeat the question so that it goes onto the recording. So if I want to make sure that I get captured right. So you're going back to Tiffany Callahan's relationship with Hannah Callahan's. Bunch of Callahans around here. In the distribution of the rules that she did, the 11,000 rules that she did, was there any attempt to sort of take a rule and ask across what networks did that rule apply? Do I have the question right? So no, so she got the rules from 6 different networks. We tried very purposely to pick different networks that had different missions and different flavors. We wanted to sort of probe the sense of the networks. And so there was actually a conscious effort as much as possible that they did not overlap as much as we could. So we looked at each rule as only belonging to that network and that network only. Maybe a different way of asking the question is, again, if you looked across the bands, you couldn't see it because it's black and white, but had you seen it in color, many of them shared a color, which represents a class of rule types, because every band was a class. And could we have looked across a color, the blue meaning atemporal, density? I don't know if that's right, but, and take a look at all the rules in those buckets across the 6 sites. That's work that was not done to see what's common about them. Clearly they're common because they were of the same class, but were the computations the same and were their approach the same? That was not done. Another student project.
I'll just add with the metadata annotations work group, one of the items we've been exploring is adding standard concepts to the vocabulary so that we can represent these ideas in a standard way. So having a concept class for data quality, which it might exist but probably isn't very full, trying to build that out. I know that if we have that, and we've been talking just in the front here about this, for Achilles moving forward, we'd want to leverage those standard concepts so that the rules that we're building aren't just strings that we put together, but rather it's just there's a concept, we can point to it, we can qualify it, and it's targeting some specific thing. And so then hopefully, maybe there's more adoption of other packages, and then it's not the exercise that you have to go through to actually, hand parse through these queries. Instead, you can categorize them more easily and see where the commonalities are.
I'm sorry, I'm just going to, before you say, I really will get to it, but I want to really emphasize that among the things that you will have the opportunity to do when you fill out the evaluation form is say that you indicate you want to participate in the metadata and annotations work group. And it's fundamental work. It's really a way in which all of this is going to yield lasting benefits for the entire community, and it needs to be done right. It needs a lot of voices. It has some excellent leadership and some excellent voices right now, but too few participants, so it's really a place to come and be heard and have an impact. So please do that. So now.
Sorry, I wanted to actually go back to the previous topic, just a follow-up question for Michael. Is there, like a gentleman in the back, I'm also new to this community, representing actually the private sector. But my question, I have two questions. For the tools that you've demonstrated to us, are there any license restrictions if a private organization were to avail of this? What are they MIT? What types of licenses? If
No, our code is all available on GitHub, freely available.
Yeah, it's anyone can use it.
Okay, so like Apache 2, MIT type.
I think so. Sorry, I don't know much about licensing, but I know it's open source.
Usually anything that's available on GitHub you can use, because they have private repos that they don't have to use it.
Okay. Next question for the rules. You had mentioned that you and your colleagues, Michael, had done like a canvas of all of the rules in different networks. Is there any effort ongoing in the community that attempts at maybe grouping or into like cartridges of rules that apply in general regardless of the nature of the data set that are just logical versus in your case pediatric is very specialized that people can say, oh, I want to use these cartridge of rules, and there's some kind of like missing.
So there's nothing to show in that area right now, but there is a movement, so that's a very nascent word, right, to try to get to this idea of specialty-specific crowdsourcing of rule sets. So the example that I was giving at lunch is that probably a nephrologist know better than anybody else sort of how those variables should look. And you want to have a specialist in rheumatology looking at your autoimmune disease kind of variables and whatever. And the idea is how to get these communities of practice involved and engaged in a way that they can contribute their knowledge to their specialty-specific packages, to use your word. It's still early stage. It's actually stealing ideas from collaborative vocabulary management vocabulary. There's been work done by the NCI, in particular, National Cancer Institute in particular, about allowing communities to kind of develop value sets and develop terms for the vocabulary. If you steal that idea and say, what can we do to get someone like a nephrologist to stay with that example, to sort of say, well, what are the ranges of things we would expect? And in pediatrics, how does renal function change over time? And and have them own that, and have the specialty societies own that, and say, if you want high quality data in your subspecialty area, you've got to take this. They've been motivated to do that in the vocabulary space because they feel like if they don't do that, then their subspecialty won't be well represented in the EHR, and therefore the quality measures that are being driven from the EHR won't represent. So there's a high motivation to do it on the vocabulary side. It's a harder sell on the data quality side as to why they should spend their time. So it's slow going. So what I just described is more a vision. There's no place for you to go and download the neurology package of data quality rules. We could probably take what we have and maybe ourselves, maybe shift them around, but I don't think we should be doing that. I don't think we as the technology informatics folks should want to be in that business. We really do want to engage the kind of the people for whom those data really have value. The other place we're going is with investigators who are trying to do a study and trying to get them to own their variable data quality. So that's a long answer to no, I'm right? Basically, the bottom line was a no. But if we could steal the model for vocabulary crowdsourcing and make that for data quality rules crowdsourcing, if we could get the same, the fear factor, I mean, the fear factor in the vocabulary side has been if I'm not represented, I won't have good measures on me. We don't have equivalent fear factor yet for data quality.
So to provide an answer for Achilles, so we organize rules into two types, CDM conformance rule and data quality rule. So CDM conformance rule says you have the wrong concept ID in the column, and data quality rule means you have implausible events after death. So you cannot specify this thing in the CDM spec. So we classify rules into these two broad categories, and if there is a DQ, so I'm showing it where it is, like you know that rule number 4 is CDM conformance and rule number 6 is data quality. And if it's kind of very bad to scroll, but further using the framework, so there was this rule type, and some of them is plausibility, some of them is completeness, and so on. So we do classify them somewhat now and try to organize them.
I just want to quickly add, what Michael I think was talking about really is a lot of the plausibility with the equality, but there's a lot, I think, to be able to create a standard. Here's some completeness, here's conformance, the other ones that are less domain or specialty specific, but I don't think there's a standard package for those either, and I think it's just taking from different.
So I'll push back, and I know you don't want to get into debate, but sort of what the data quality is all about managing expectations, right? And what you'd expect being done in a pediatric kind of along the age groups, what's being measured, what's important, what's relevant. Your completeness is going to change until you get into adult. Now maybe it is true until the geriatrics, when again the things change. So I even think very basic things, and it may be different. This is an international effort, right? And so the frequency in which various things are measured may be very different across different countries. So I think you have to be very careful that even the simple stuff really quickly unwinds.
Yeah.
I just want to follow up a little bit on the, Michael, you mentioned the fear factor not being there for the specialties that could define the rules for nephrology, or for example. I think when researchers are coming, though, that's the other group that you're saying, and they are motivated. And so I think just some systematic effort to provide a way to capture that information when a particular research project comes in, and I think you guys are doing that to some extent. Am I right? Or
we're trying.
You're trying
to develop a kind of systematic way and to get into what we're calling more kind of semantic DQA.
Yeah, I think it's just one of the great losses that's occurring continuously as these things get used and we're not capturing that information. What gets learned about the particular relationships, the things that should be encoded into rules and preserved and shared. That's a real opportunity loss every time we don't do that. So I would personally say that that's a high priority area. What other questions do we have? Sir?
I have probably a more collective comment to speak, so you should be able to hear yourself echoing. Can you hear me? I'm more probably the collective comment and question to all the speakers, starting from Michael's data completeness to the reality of missing data, whether it's clinical trials or observational study. The reality is sometimes is missing data. So I think pragmatic approach certainly has some unique advantage and can answer some question that pragmatic approach can answer. But at the same time, I think it's important to set up predetermined criteria when design protocol, how we treat missing data, or how we treat missing certain segment of visit. Sometimes we have missing entire visit. Sometimes we missing just certain number or some number of the visit. So a predetermined criteria when designing the protocol. It is also it is important to have such predetermined criteria because that will avoid data mining or perceived data mining. This is one. The second thing is about, I think it's about related to quality control as well, but it's more on the programming, similar like a biology concept, inter-assay or intra-assay. When we're using the algorithm design, the programming and have this, is how confident we are with the software that we develop. I think currently in some hospitals, in the US, some hospitals, their IT field is quite advanced. IT have those like alert according to the same guideline. But still, there is not in that stage. I'm confident this is an algorithm that we designed. You have to really pay very, very close attention if it's not completely rely on it. So that has some legal aspect as well, to have such inter and intra-assay on the development software. That's part of for the quality control, or data quality or quality control aspect.
Sure. Yeah, the confidence in the data, I think, is one of the use cases that we have with the metadata scheme that we're developing, in the sense that if there's some kind of known blind spot in the collection of that data, whether it's missing or maybe the algorithm that's used may not have great accuracy or as much accuracy as we want, to be able to tag that and have that information in the metadata schema and have that available as you're designing a protocol, that's very important because then when you're writing a protocol, you're going in completely informed about what types of fixes or adjustments or decisions you have to make in selecting that data set for the study. So I think I'm just saying that I think that use case is a very strong one. I think we definitely want to have that as part of our work group.
So I just only have one comment about sort of the nastiness of missing data because it keeps coming up. There's also information in missing data. I mean, the fact that data are not there is in fact informative. So it is not always the case that missing data is in fact an enemy. It is telling you something. It may be more about workflow or clinical practice. And again, we're an international community, so that those may be different. But everybody speaks of missing data as this horrible, horrible thing, and I get it. But it is also informative.
Bad data too.
Bad data is informative, or
yes, it's very informative. It tells me for one thing how much I can trust the field. So if I get rid of all the bad data that's obvious, there's still bad data there because they were entered by the same people.
Because
I just don't know it anymore.
Got it. Yeah, well, this is what drives me crazy. Sorry, I'm going on hobby horse a little bit. In the method sections of many scientific journals, there's this one line there that says, "and the data were cleaned," and then they go off and say, go off all the relevant. What the hell happened in there? What does that really mean? Were they like massaged and squeezed into miserable, or did they just do a 2% extreme trim? All you know is that the data were cleaned, and that's all you know. So, anyway, sorry.
It's appreciated. No, it's like the passion. It's nice. It's nice. And I don't know how literally you meant the question in terms of software. You if that was an analogy or if that was a literal question about the faith in software used to detect data quality issues. Was it actually a question about what steps are being taken in the OHDSI community to ensure the accuracy of the algorithms that are being used to detect data quality issues, or did I misread that? You. Yeah.
Okay. Yeah, I think you meant about like inter-assay is right. from the biology, biochemistry, or biology aspect, interassay as different sites, different people doing the same thing, and whether come from the same result. Intra-assay, you do the same reagent, and then you see whether that's a variation, whether it's normal variation, or it's just, variety of, so different quality control or different error could happen at different places.
Yeah.
So that's part of, as a big quality control among different programs.
So two different programs trying to assess the same data quality issue should come up with an equivalent
Or set up the
result.
same algorithm, with AI.
Right.
Come up with
Right.
so.
That's a good point. And there is an evolving and very nascent but an evolving set of software quality code standards within the OHDSI community that's it's just getting scoped out, and I think it's a big open source community. Everybody contributes in any way they want, but there's an effort to help people be aware of all kinds of issues, because some of the software in the community has a device-like nature. It's actually being used to predict things that might have clinical importance and so on. And I think, anyhow, it's a little beyond the scope here, but other questions? So, yes. And maybe I'll hear.
I have a question to Connor. During your tutorial, I found some value set in your package, and I found out that it is well developed and well organized. How do you find this value set? How do you develop this value set?
It's a great question. So a lot of it was actually done by...
Over here.
So the question was about the value sets that are included in our DQA toolkit. So a lot of those value sets were defined by my predecessor, Ritu. But going forward, we really want to start using the metadata warehouse in order to actually really drive these thresholds and the value sets that are included there using previously recorded data. So I'm not sure as to the exact history of it, but maybe
It's from the Friday session.
Oh, from the data model group? Yeah.
Yeah.
So do you mean value sets as in acceptable values for certain fields and what that means? Yeah, so those are set forth by just standards that we develop as an organization, like as a PEDSnet group. It's us and all of our sites who contribute to this kind of thing, and Evanette, who's here, who is in charge of keeping the standards and organizing all that information. She has that. She's developed those standards, and the data quality pick up on that in order to make sure there's a lot of conformance to what's specified in those standards. And then there's a separate threshold of a separate issue of just thresholds. How do we set those thresholds? And it's been kind of ad hoc for some continuous variables. What should we consider a data quality problem versus not? And for things that are not necessarily like specified, gender is very easy, right? But things like, how do you know when your distribution of visit dates, when there's like an outlier in frequency, how do you define that? And actually that's an ongoing problem for us. We've been kind of using clinical and kind of research expertise to kind of feed into that. But just as recently as 2 weeks ago, we received feedback like actually that data quality check is almost never an issue for us, and we have to like go back and check that. So it's a very iterative sort of process. Which working group?
So just to put a little bit more spin, every Friday for the last 3 years, all of the PEDSnet sites, all the 8 PEDSnet sites get together and talk about issues with the data model. And this is where these value sets have come from. What are we going to put in? What are the concept IDs that we are going to use as the community of 8, as our agreed upon code or codes And, we argue about them, and there's a lot of sort of back and forth, and sometimes I'd rather have a root canal than attend a Friday meeting. But they take a while to kind of work their way through. And then they go into this document I've talked about. I've called it the PEDSnet conventions document, which I'm very proud of. The group should be very proud of. And it's quite large now. It's 80-some pages, I think, so I have near 80-some pages now. And it outlines these decisions. These are the codes that we are going to use. You guys, which is, comes to me as a data site, have to map your data into this value set, and then that gets handed to the QA team okay, are we using those? People going outside of those? We have rogue concept IDs. Now they may be valid in some other context, but we, as our sort of sub-community, have said these are the codes that we're going to use. So I do think it's a great idea to maybe share those with the value set working group. They're really pediatric specific. They're really geared for peds.
Yeah, defining balance is really important for detailed developer because we don't know total value sets, so we don't know how do we code our local code too. So
So is there an OHDSI value set working group? You implied that there was.
I just want to know, is there any working group?
Oh, well, you're okay. So I thought, so maybe we need one. Okay. Or maybe you guys need to take it out. Got it. I don't know.
You're going to start a value set working.
Is that part of what Canvas is trying to do, or is that not?
Is that right?
Well, to a limited degree, I wouldn't call it value set working.
Because it's more just like how to best use the CDM.
It's conformance.
Right, and I don't know that that's really valuable.
We need one.
I mean, so I presented the Themis database. So would you consider permissible units per lab test to be in the scope which you're asking? So the answer is there is a subgroup which develops that, and it's a Themis subgroup. It grew out of work group 1, and now the Themis is in full. So partially answer to your question, yes, that Themis actually does do that.
Yeah, I think though, and that's absolutely true. I just think that I think it's a good idea to have a special group dedicated to that exclusively. I think they would certainly have an impact on Themis and other things. So if there's other thoughts.
And actually, one thing I wanna plug in here. So the CDM version 6 was just released. So I want to show that what's the future plan for. If you now go to the wiki and for a table, and if you go to the ERA table, here we go, it's already shown here. So previously, in version 5.3, you would look at visit detail, you would see the specs for the table, and at the bottom, there would be a not perfectly organized set of conventions. And I have just talked to Claire as well to how to reference these. So we have made up a convention that visit detail .5, and so this will be the 5th convention for the visit detail table. And right now at the last, at the last Themis working group, we created a subgroup which is gonna go after trying to attach a heal rule to each of those conventions. Which is almost exactly what PEDSnet is doing, so we are trying to catch up with that. So the assessment currently ongoing is saying, okay, we have 200 of those conventions, how many of them are checkable by SQL, and how many are we checking now? I have to say we are checking some of them now, and so maybe that's just a kind of related information to your question, that the conventions are now numbered, and heal will go after the numbered ones, and there will be a better reference to the conventions. We were even talking about that if you look at the specs for PEDSnet, they put the conventions as the 4th column next to the description. So as you are, as an ETL developer, you just says, okay, this, it's an integer, and it's it's a value, numeric value. But then you say, oh, reference convention 7, 8, 9, and 15, to see relevant conventions for that. So it's not come to that will be kind of a proposal to the group to possibly consider, but it's moving to that direction. And just, that's a new thing in version 6. The conventions are now numbered, and there will be a better much better a massive effort to go after them through heel checks. And we can now just say, okay, are you talking about person convention 7 and so on?
I just want to add one thing. I think coming up with a standard way of doing things for everybody might be challenging because, as I'm thinking about, these decisions that we make during these meetings, like collaboratively across PEDSnet institutions, a lot of them, for example, how do we deal with conditions in EHRs that resemble procedures, or, something that looks like it should be, like glucose elevated, for example. How do we deal with the semantics of that? Because it might be from the source table in Epic, a condition, but it's being rooted to measurement in the OHDSI, so there's a lot of specific decisions that we've made in order to just get on the same page that I don't know would necessarily be the standard way that everybody wants to do it. So I think when we think about these, some things are easy, like gender concept ID, and grabbing those. The things that are trickier require more thought, and of course the continuous variables are very difficult as well.
Actually, we're going to have one last question, and it has to be quick because we have very, very little time left.
So I want to present a little bit of a contrarian view. We work with a number of different EHR data sets, and the only reason why we can support all 50 EHRs, the only way we can do that is by following standards like FHIR or whatever else. And one of the experiences that we have had is taking that approach versus the ETL approach is a little bit cleaner because there's a lot of continuation of care down. There's a lot of maturity already. If you're trying to get data through that approach, and the data quality is a lot better if you're, versus the ETL approach. So I'm just wondering if you have a perspective on that versus the ETL approach.
Well, I think as those mature, and as you say, they're really getting there, and they're really starting to be standard. They, in fact, may be the preferred way to start to collect data. And particularly sort of the more strict standards of FHIR. The CCD and the CDA a little looser in their semantics, but the FHIR standard is trying to be much more clean, and it's being more widely adopted. Now, again, I don't know what that means internationally. I haven't been following that, but I could definitely see that, especially when bulk messages are able instead of an individual patient protocol, which FHIR really right now is optimized. So if we have 4.5 million patients that don't want to send the system 5.5 million messages and get back 5. So as the bulk query mechanism of those sorts of standards get better, it'd be nice to do it that way. Believe me, that's the great work, because that pushes all the semantic mappings right back down to the, I have some slides that show the 30 some odd different places in which blood pressure are captured in our EHR. And of course, they get stored in different places in the back end, so the ETL process has to find them, let the FHIR folks find them. Let's hope they find them all, but again, they're motivated. So yeah, I could see a different world. I can absolutely see a different world. I don't know, for those of you who are not from the United States, is FHIR or the Clinical Document Architecture, CDA, being adopted in your countries?
Who is from outside the U.S.?
Johan, are you guys doing FHIR? Are you guys doing CCA?
Interested in it, but no problem.
Is there something equivalent in Europe that is sort of like an IHE profile, I think that? So, we'll just have to be sensitive to that, but I absolutely can see that. Because again, I'd love to push that all down to someone else.
Yeah, I don't know. We haven't used that approach at all. So a lot of our work has been very ETL.
Yeah. Well, our FHIR interface is still single patient oriented. So
Yeah,
I'd have to send messages to every single patient.
Okay. I think that's going to wind up our QA session. Thank you, everybody, for your questions and for all your great answers.